Rockfield. Um, Pick via state analysts in tunneling or mining or running operations. I welcome Dr. Brett Schneider. The floor is yours.
Thank you very much for the introduction. Welcome to our presentation. My name is Jörg Brettschneider. I'm one of the founders and the COO of Rockfield GmbH, and actually we do what our name is saying. We are sensing something where steel meets rock in order to destroy it typically or to excavate it. I will just try the presenter first to get something running here. So this actually doesn't work. Maybe we'll have to wait for 1:10. I don't know. So actually I will start. What we are doing is bringing sensors to these kind of tools which are put on excavating machines. Typically excavation is done by drilling and blasting in mining industry. That's a very traditional procedure. We go to the more modern kind of excavation, which is just done by cutting the rock. And you can do this for many kinds of rock, not of all, of course, because there's very hard rock in this world. But we can do it for many types of rock. And in this area of excavation, there are many questions to answer, and we think we can put some of the answers to them. So hopefully I would like to start my presentation, but it's still not working. So maybe Technik can do something about it.
Yeah.
Yeah. Well, of course, we are in the mining business. In the mining business, we have one big problem. It's not just the endiness and the ending of resources. It's just also an image problem. So we want to overcome this because otherwise we would not be able to provide society with commodities we need all. And one means of doing that actually, no, that's not the right one. That's not the right one. I gave it yesterday to you, the English version of my presentation, please. This is a German version, it's very long. I don't want to go into that. So, in order not just to waste time, as you see here, oh, there's a different monitor. You don't see anything. Well, I already talked about drilling and blasting, which is a very dangerous thing to do, and it also has many other consequences. You have acidic and toxic gases coming from it. You have to blow them out of the mine, and you have an extensive use of resources in drilling and blasting because you have to process all the process chain all over with material just from your commodity and surrounding rock. And so our first approach was to try selective mining, especially with cutting tools. And the problem is, of course, that you don't see anything if you apply these cutting tools. And so we said, well, we want to bring sensors to these cutting tools. And this is a very challenging task because typically there are very hard conditions on these kinds of tools. 1000 G is something which is experienced regularly when these tools are getting in contact with rock. And so, may I just give the stick again? Yeah, I did it yesterday, so I'm quite sorry for that. Sada, marketing order and the newest presentation, please. I'm sorry. I gave the presentation yesterday here to this stuff, so something went wrong somehow. Well, actually, this is very hard conditions, and normally industry didn't believe that we would manage that, but we actually found a way. We developed a solution, a contactless sensing solution for these kind of picks, and this contactless sensing solution had to be proven. First of all, does it work? Does it provide data at all? Can we use this data, and does it survive? And that's actually what we did in 2 years of operation as a project team, and actually 1 year now as a founded company, as a startup company. So I would like to show you, maybe we can go something a little bit here and find something I wanted to show you either way. Of course, the advantages of cutting, I would just go shortly about it. We have less dust, we have less noise, we have less vibrations into the ground, less damage also to the bedrock, and this is also a safety problem. And of course, we have no material going, poisonous gases going out from that process. It's a very a process which is more friendly to the environment, of course. We have one big problem, which is high wear on the tools, and that's most time it's very limiting the applicability. Well, and now I see we had now the right presentation. Maybe you change on that. Thank you very much. So everything on that I already told you, and I will try to explain how we can make a contribution to these very, very ambitious goals to see a more efficient, a more sustainable, and a more reliable mining in the future. So actually, cutting in mining is done with tools like that, with a cutting machine, an excavator, with a cutter head, with many of these picks on it. And these picks are in very rough contact with the material. They are very hardly sustained, and hopefully we already had this. And we want to address the problem of high tool wear, because otherwise, normally we will start with a pick like that, but in the next place it will be normally weared out. But if the problem is that these picks must be movable, they must change their position all the time in order to have normal wear. But if you have a blocked pick, this will get very soon to a kind like that, and this will destroy the pick in maybe some minutes. And operators don't recognize it early. Otherwise, if we have a sensor on it which could detect this condition that the pick is blocked, then the operator can get an early warning and get out of it. So we have many functions which drive up the costs of these picks, and a very big part of it is planned and unplanned downtimes of the overall machine. First of all, for regular pick inspections, which is a daily business. But if something is breaking down, you have maybe days or weeks of downtime, and that's very costly, especially if you go into tunneling applications. 1 hour can cost up to 30,000 euros. So it's a very interesting thing to avoid this, and this is what we're trying to do with our Rockfield company, with our approaches. We want to reduce the regular pick inspection, because if you have constant feedback from your picks, you can say, well, okay, we can do it a little while, or we must change earlier in order to have regular operations. And of course, if we avoid accidents and damage, grave damage to the machine, we can completely avoid these hazards. And this is how our system looks like. We have our sensor on the cutter head, and this sensor is constantly measuring characteristics of the pick movement. Actually, the movement here you see, and you can see it on our booth 502. We have it actually in operation there. It's a contactless system, very robust. Actually, it survived 50 hours on cutting concrete already, and it's actually the system we are presenting there. We have, of course, a wireless data transmission to a PC or something like that, which then will calculate qualitative measures, just think of it as some KPI actually, for the pick blockage, for pick loss, for pick wear, and we can then monitor that and visualize that for the operator. And another application which we first wanted to go in was selective mining. Actually, we can see differences in if the rock hardness is different for while cutting. We can see differences in the reaction of the picks, and then we can transfer that into a kind of a map of the face and say, well, operator, you are here, it's your ore zone, and this other zone where the material is not so rich in your ore. The system consists of typical components for such a system. Of course, in first place, the sensor on the pick, some pre-processing for the data transmission, calculating of the values and then visualization for the operator in the first place, but if you look at the future, also for an autonomous machine control. So, how did we do it? Did we do that? It's just a journey. I want to take you a little bit with me. We had a testing rig which just has one PIC stationary installed, and we can move a probe below it. And this has been done very, very many times in the future, before. Just recording the cutting process with the camera, measurement of cutting forces, learning many things about cutting. What we did newly was not just this what is classically done, but we measured, oh sorry, it's a piece of German, we measured the movement actually of the PIC in its holder. And that was the new one, and we had to apply, of course, different sophisticated reference sensors for it, especially a laser system which had to be hung up on a crane in order to work properly. And after we evaluated our approach, we wrote a patent, and we started building up a mobile test rig with an excavator and a concrete block and a cutter head on it, and put our sensor electronics on this cutter head. And actually, the system looks like that. You have the excavator, you have the cutter head itself with some additional sensors on it, and we have the sensors itself on the PICs, and then the data transmission to our back end. And all this can you see on our booth. This is how it looks in reality. Of course, after 10 minutes of cutting, the new cutter head is looking like that. It's actually a very, very varying process. This was the starting phase. And we had this under test for quite a long while. And you can see this for this moment here, how it works. And it needs certain skills of the operator, of course. And he's sitting here, a natural talent who just managed to learn this in 1 to 2 weeks, essentially. And while we are doing this cutting, we are measuring constantly data, recording it on the device and sending it to our receiver and evaluate the data. So it's quite a hard action, and can be quite harder if you possibly get into steel, if you do demolition on concrete, for instance. So that's normal and very brave behavior. Yeah. Actually, our results are very promising. We had no downtime of our sensor or of our system after 50 hours of cutting operations. And we had our patterns, which we expected from the physics of the braking process, in our data. So we will very well go on. We have certain data for these different positions for the PIC. We have the PIC bouncing after the PIC is leaving the rock, and we also see PIC rotations. And this is what nobody else has done before, so we think can come many good things about it. With the rock itself, it's not so easy because the concrete we used, it has very hard rock in it in very small grains, and they will put a little bit on the data. So our next step will be go outdoors, go to the mines, cut there. We'll start next week actually in Porphyr, tough mine, open mine, and very soon we'll go to a salt mine underground and test it there. That's us. We established the company 1 year ago. We are going forward. We are looking for venture capital now in order to invest, in order to develop further, to extend the team. And of course, we are doing these kind of projects. The next one actually is in the salt mine in Heilbronn, where we'll go on this machine and install our sensors there. We have several partners already helping, very helpful in that. Industry is very interested in, so we started with industry from the beginning. And that's just my summary of what we can do technically, that's on the left side, and what we can do for the process of mining on the right side. So we are happy, hopefully, that we can help in wear optimization and process optimization in excavation. Another application I didn't mention so far was warning of unstable material ahead, because if you're cutting through a bulk material and then you get an unstable zone, of course the PICs will react differently, and we hopefully will see this pattern also and then send a warning to an operator, "Wait, take care, there can be that material is coming down, so you have to take care for yourself." Of course, selective cutting excavations. Recently, we had many feedbacks from industry where this can be applied. It's not so well known already, but it's growing, and we think that it's some future for excavation, especially in Germany, where we have many small deposits which are not economically viable so far. But if we have selective cutting excavation, we can do this mining very well in our environment in Germany, in Saxony, especially where we are coming from. And in the far side, for looking for mining 4.0, we can say, well, if we can get continuously data from the phase and from the material we are cutting, we can also put this data in a more broad scheme and bring it into maybe for a model update for the deposit model for the mine operations or any other applications for autonomous operation. So that's what we wanted to do. Our focus now is on the wear optimization, of course, because that's what the industry is needing most and is asking most for. And that's our team. In short, you can come to our booth at C0 or B0 502. B0. Yeah, okay. The lab here. And very welcome for questions, of course. Thank you very much.
Yeah, thank you very much, Dr. Brettschneider. It was an interesting